In this question, we have given that tan of cos inverse x is equals to sine of cot inverse of 1 upon 2. And we have to find the value of x for which this equation satisfies. So, first of all, I will convert cos inverse x into tan so that it can be simplified, and cot inverse of 1 upon 2 to sine inverse so that it can also be simplified. So first of all, I am calculating the cos inverse x in terms of tan inverse. So let us assume cos inverse of x is equals to angle theta. So now I am taking a triangle, right angle triangle, whose this angle is theta. Since cos inverse x equals to theta, so the base will be x, the hypotenuse will be 1, and by Pythagoras theorem we evaluate this side and we will get x equals to 1 minus x square. So we can write as tan theta equals to under root 1 minus x square divided by x, or theta equals to tan inverse of under root 1 minus x square upon x. And since we assume that theta is cos inverse x, so we can write that cos inverse of x equals to tan inverse under root 1 minus x square upon x. Similarly, we evaluate cot inverse of 1 by 2 in terms of sine inverse. So again, let us assume cot inverse 1 by 2 equals to theta. So cot of theta will equals to 1 by 2. Now let us take this angle to be phi so that you can differentiate between them. Let us assume this angle is phi. Since cot phi equals to 1 upon 2, so let this assume this side will be 1, then this side will become 2. Now again by Pythagoras theorem, you can evaluate this side. It will be root 5 under root of 2 square plus under root of 1 square, that is under root 4 plus 1, that is under root 5. So we can write that sine of phi equals to perpendicular, that is 2 upon hypotenuse, that is root 5. So we can write as phi equals to sine inverse of 2 upon root 5. And as we already read that phi is cot inverse 1 by 2. So cot inverse 1 by 2 is equals to phi, that is sine inverse 2 upon root 5. Now I am using these two values and applying this in our required equations. So from here we apply these values in this equation and we will get tan of cos inverse x, that is tan inverse under root 1 minus x square divided by x equals to sine of cot inverse 1 by 2, that is equal to sine inverse 2 by root 5. We know that tan inverse of tan theta x equals to x, so it will be simplified to 1 minus x square divided by x equals to, and sine of sine inverse x equals to x, so it will be 2 upon root 5. Now squaring both sides, we get 1 minus x square divided by x square equals to 4 upon 5. Now rearranging them, we will get 5 minus 5x square equals to 4x square. Now we are adding 5x square on both sides, we will get 5 equals to 9x square. We can also rewrite as 9x square equals to 5, which will be implies that x square equals to 5 by 9. Now taking under root on both sides, we will get x equals to plus minus root 5 upon 3. We are here getting two values. Always when the required value is evaluated, always cross check it once. So I am cross checking it. So now I will cross check it. Now first of all take x equals to plus root 5 upon 3. On applying this to this equation, we will get tan cos inverse of root 5 by 3 equals to sine. First we let's find the value of LHS. So it will be 10. Now again converting it using the formula that we have derived earlier, that is cos inverse of x equals to tan inverse of 1 minus x square divided by x. So by using it we can write as tan inverse of under root 1 minus x square, its square will be 5 by 9 divided by x, that is root 5 by 3. Now as we know that tan inverse x equals to x, so the remaining value will be, if you simplify it, we will get root 4 by 9 divided by root 5 by 3. Further we can write it as 2 upon 3 divided by root 5 by 3, which will be equals to 2 by root 5. And on the right hand side we have earlier proved that this is 2 upon root 5. So the value x equals to root 5 satisfy this equation. Now we will check our second value, which is x equals to minus root 5 divided by 3. So we can put this value in our equation's left hand side. Here it is equals to RHS tan of cos inverse minus root 5 divided by 3. We know that cos inverse of minus theta is equals to pi minus cos inverse theta. Now we will use this identity in this expression and we will get tan of pi minus cos inverse root 5 upon 3. Since we know that tan of pi minus theta, we write it here, tan of pi minus theta is equals to minus tan theta. So by using it, we will get minus tan cos inverse root 5 by 3. Here we have already proved that tan of cos inverse root 5 by 3 is equals to 2 by root 5. So it will equals to 2 by root 5, which is not equals to RHS. So x equals to minus root 5 by 3 is not the solution for this equations. So I would highly recommend that always cross check the evaluated value once, so that you do not take any extra values. This happens because when you are taking root and it will become a quadratic, so extra roots are sometimes extra roots are generated. So that's why the answer for this question is option And second, that is plus angle root 5 upon 3 only.